Hey guys, hope you all are doing well. Welcome back to the channel. Today we are continuing our data visualization using Python in Seaborn series. This video is going to talk about extended box plots using Seaborn. And if you're wondering what an extended box plot is, well, make sure you watch this video right up to the end. Now, if you haven't seen any of my previous videos on Seaborn, click the link right here or click the link in the description box and make sure you watch all of them. My videos are made for beginners, for everybody who wants to code. So make sure you follow each and every step, understand each and every line, pause the video where you need to, and make sure you get everything right. Let's get back to the video and let's make sure that we understand extended box plots well in today's video. Now, to make sure that everybody understands and everybody is able to visualize the illustrations well, we're going to be using a very simple data set that Seaborn offers, which is the penguins data set. And while we are coding, we'll use that. But before that, just to recap very quickly what a box plot is. In very simple terms, a box plot helps you visualize the distribution of a set of data. Now, the distribution is divided into three main parts rather. You have the first 25 percentile, 50 percentile box, and then the next 25 percentile. And majority of the data is represented by this box. And the size of the box, depending on how long or how thin it is, tells you how much the data is distributed. All right. So if it's long, that means data is distributed much more evenly across the entire data set. If it's very thin, that means there's a large volume of concentration or a large concentration of data in a very small window of data, in a very small window, and the rest is just small scattered points. Now, what's the problem with the box plot? Why do we need something called an extended box plot? So an extended box plot, also known as a letter values plot. So it was first called letter values plot before it was called an extended box plot, primarily allows you to visualize the distribution a bit better. Now, assume you have this sort of a distribution and you were just to visualize it using a box. Now, the box plot would just give you this first central box that you see here, and you would just get a line on either side. An extended box plot, on the other hand, gives you smaller boxes on either side of the center box or the first box to tell you how much the other pieces of data are distributed as well. So if you have smaller pieces of data after the 50 percentile, then you can get a distribution of that to understand whether it's a lot, whether it's less, and that gives you a better visualization of the distribution as a whole. Now, you could also do this using a box plot along with a histogram, but if you wanted to visualize it just within the box plot, then this is the right thing for you to do. Obviously, Python gives you a way to plot this. We're going to try and do that using Seaborn today. And hopefully that'll give you a better understanding of how an extended box plot looks and why it is so important to know what an extended box plot is. Let's get right into coding. So I'm using a Google Colab notebook to write my codes. You could do the same, or you could use a Jupyter notebook or any other IDE that you feel you're comfortable with in order to follow along and code with me. First things first, we're going to import our libraries, the libraries that we need in order to visualize these plots. So we're going to import matplotlib, and we're going to import Seaborn. All right. So let's make sure we run that. And okay, we've successfully imported our libraries in. Let's get another code block here so that we can write the next piece of code and bring in our data set. Right, for some reason it doesn't allow me to. Okay, there we go. Put in a code block. All right, so the next thing we're going to do is we're going to load our data set. So we're going to say load the penguins data set. Right, now to load the penguins data set, let's create a new data frame or a variable called penguins, and let's say sns.load underscore data set as penguins. So this is the data set that we're going to get in as well. And to make sure we have loaded our data in correctly, we're going to look at the top 5 rows of data to make sure it's loaded in without any errors. It also gives us the avenue to understand our data a bit better, and that's what I'm going to do right now as well. So our data set is quite simple to understand. It's a penguins data set, so we have the species of penguin in the first column. Second column is the island they are typically found on. We have the bill length, the bill depth, the flipper length, the body mass, and the gender of the penguin. Now, for those of you who are not familiar with the body parts of a penguin, I have just the right thing for you. So if you give me just 10 seconds to bring in an amazing image to explain the body parts of a penguin, you'll be able to understand exactly what they all are. So this is the flipper that we saw in the data set. This is the bill that we saw in the data set. This is the body that we saw in the data set. Now you know, now you're clear. All right. Now let's go ahead and plot our box plot first and then compare that with the extended box plot. All right. So to plot a box plot, the function that's used in Seaborn is a box plot, right? On the x-axis, sorry, on the x-axis, we're going to use the variable or the feature species. And on the y-axis, we are going to try and get in the flipper length. And then the data is going to come from the penguins variable or the data frame that we loaded the data into. Okay. So what we are trying to do is we're trying to look at the distribution of flipper length for the different kinds of species of penguins. So we're also going to give a title to this plot. Let's say box plot species versus flipper length. All right. So I hope you're clear so far. So let's try to run that. Once we run that, it should give us a traditional box plot. So the traditional box plot looks something like this, wherein you have the 3 species of penguins here, and along with that you have the distribution of flipper length of each of those species. So the box tells you that 50 percentile or a lot of the data is concentrated around, let's say, the 185-ish to about the 195-ish values. Similarly for this, it's about, let's say, about 190 to about 200, and so on and so forth, right? So we don't understand how the rest is distributed just by looking at this, but we know it's distributed in these lines up to the whiskers. Okay, let's try to do an extended box plot and let's see whether that helps. So the function that's used to plot an extended box plot in Seaborn is called box n plot, right? So that's boxenplot. It's box n plot. And within the bracket, again, we're going to just say x equals species. We're just going to put down the same thing again because we want to visualize the same thing, right? Then we say y equals flipper length, and then data equals penguins. So that's where we are bringing in the data from. And then again, let's give a title to this. We'll say plt.title is extended box plot. species versus flipperlin, right? Let's go ahead and run this and see the difference in comparison to your box plots, right? So now if you look at this, you will see that along with your bigger chunk of data, the box that shows you the bigger chunk, we have smaller boxes on either side that shows you the distribution of the other parts of the data outside the 50th percentile. So which is the 25th percentile here, the 25th percentile here, up to the outliers. So this tells you that there's a smaller distribution of data, let's say for example, between 182 to 185. And on this side, let's say between 195 and 197. So if you have a very huge amount of data, a very large amount of data, then this sort of visualization can help you understand the distribution much, much better as compared to a simple box plot. And that's the real use case for this. All right. So the comparison between a box plot and the extended box plot, to summarize, is that the distribution in an extended box plot gives you a much better identification of the spread of your data, about how the data that is going to the whiskers or to the ends of the plot are distributed as well. All right. So hope that clears it up. Within Python, you can plot this using Seaborn, using the box and plot function that allows you to give, plot an extended plot, extended box plot, and try to use it and see how it works for you on your data set as well. Right. So hopefully you've understood how to plot a box plot and an extended box plot, or as we also know, it's called the letter values plot. Try it out. Let me know in the comments whether you are able to plot it, how it looks like for your data set. Put an image down in the comments. And if you have any questions related to box plot or extended box plot, let me know as well, and I'll help answer all your queries. If you have liked this video, if you've liked what you've seen, don't forget to press the like button also. That will help me immensely. At the same time, don't forget to subscribe for more such amazing videos. And also share this with any friend or colleague, family, friend, relative, anybody who's learning Python coding, who's learning data visualization, so that they can pick up on something new as well. All right. Keep a lookout for my next video that's going to bring you even more amazing things. Till then, stay safe and take care.